This is a screencast for Chapter 9, Question 9.5b4. Now, this problem has three payments due at different times, and we are asked to calculate the equivalent single replacement payment. So you should be thinking about an equation of equivalence. We have payments, three payments on the left-hand side of the equation, and one replacement payment which has to equal it. So first of all, let's make the focal date 2.5 years from today. That's because we are asked for the equivalent single replacement payment 2.5 years from now. As usual, make some sort of a sketch of the time, and I find it easiest to label each point with E1, E2, E3. It doesn't matter what letter you use, just to make sure that when you're doing the calculations you don't mix them up. Now notice that our first payment, E1, is for $600. Now that payment is in the future. When you look at E1, it's 1 year from today, but it's still not at the focal date. So in 1 year's time, when you have to make the payment E1, if you are standing at E1, the focal date is still in the future. So therefore it's a future value problem. I is the interest rate divided by the number of times in the year it's compounded, which here is 12. So therefore I is 0.00625. Now notice that the number of years between the time that you have to make that payment, 1 year from today, and the focal date is 2.5 years minus 1 year, which is 1.5 years. So the time gap between E1 and the focal date is 1.5 years. So 1.5 times the number of compounding is 18. So n is 18. So therefore we can do our usual future value problem, use the future value formula, and find that the value of $600 in 1.5 years time is 671.21. We move on to payment E2, which is for $800. Notice that E2 is 6 months after the focal date. The focal date is 2.5 years from now. Payment E2 is due 3 years from now. So the time gap between them is 3.5 years less 2.5 years, so that's only half a year. Now when you are standing at the focal date, that payment is in the future, it's after the focal date. So we are calculating everything at the focal date, so therefore we use the present value method. N, therefore, for this question is a half, because it's half a year, times 12, which equals 6. Notice that we are using the future value method. So here the power is to the minus n, which is to the minus 6. So 800 brackets 1.00625 close brackets raised to the power of minus 6. The third payment is for E3 is for $1,200. That is 6 years into the future, but the focal date is 2.5 years into the future. So the time for this one, the number of years between the focal date and this payment, is 3.5 years. So again, this is a present value problem with n is 3.5, 3.5 years, times 12, which equals 42. And therefore we can make our present value equation E3 equals 1200, open brackets 1.00625, close brackets, raised to the power of minus 42. Now, because all of these payments are brought to the focal date and we are making our combined payment on the focal date, we can combine these payments together, call them X. So X, the payment that you make on the focal date, equals E1 plus E2 plus E3. And that is the solution. You would pay 2365.57 on the focal date in order to cancel, to make good on all these payments. Thank you.